working on the solving quadratic equations by completing the square method. Now, completing the square method just have 3 steps. The very first step involves arrangement. You arrange the equation into this format. Ensure whatever quadratic equation you are given, you should arrange it in this format. So you have x squared minus 10x equal to whatever the constant is. The second step is to get half the coefficient of x and then square it. Half the coefficient of x and square it. Half of the coefficient of x here is minus 10 over 2, that's half of it, and that'll give you 5. Now you square 5. Then the next thing you do, the third step is to add that coefficient of x, half the coefficient of x, add it to both sides of the equation. So I'll have x squared minus 5 square equal to 75 plus, it's actually a plus here, but plus and a minus made you a minus, so you have 75 plus 5 square. So let's solve this. Here we have x minus 5 all square is equal to 75 plus 25, which is 100. Then if you solve this, you get square root of 100, x minus 5. Now what we're doing here is just reducing it. This will give you 10. Then you have x is equal to, now when you square root 100, when you move this square root to the other side and it gives you 100, the square root of 100 is plus or minus 10. You know, if you do minus 10 square, you're going to get 100, and if you do 10 square, you're also going to get 100. So you have plus minus 10. Then you move this minus 5 to the other side, you will have 5 plus minus 10. Now x can be any of this. X could be 5 plus 10, which is 15, or x could be 5 minus 10, which is minus 5. So these are your two answers to the quadratic equation by using the method of completing the square. So here we have 15 and you have minus 5. Now they're asking you what is the value of x plus 5. So x plus 5 could either be 15 plus 5, which is 20, or x could be minus 5 plus 5. Minus 5 plus 5, which is 0. Now you hear they say x here is less than 0. The only answer here that's less than 0 is minus 5. Minus 5 is what's less than 0. 15 is not even less than 0. So that's why we use minus 5. Now be careful. If the option here was if 20 was the option and the root x is less than 0, you should be careful not to put 15. If you put 15 plus 5, you would have gotten 20. But that would have not been the answer, since they mentioned that x should be less than 0. That's why you should have put minus 5. So always be careful with SAT questions, because sometimes they will put the answer, some of the answers, that will make you think you are right, but yet you are wrong. So let's move to question number 2. Question number 2 says if x squared minus kx equal to 20 and x minus k over 2 equal to 6, which of the following is a possible value of x? So we're going to do that by difference of two squares method. We're going to solve this by difference of two squares. So the very first thing, remember what we said we should do, getting your this into this form, and then getting half the coefficient of x. Half the coefficient of x is minus k over 2. We have that. Then we square this. We're going to square this and add it to both sides. We're going to square it and add it to both sides. Now you know what you're going to have on this side. You'll be having x squared minus k over 2 minus k over 2 all square is equal to 20 plus k over 2 all square. But because of this minus, when you square it, you'll be having you'll be having plus, because minus k square is plus k. Okay, so you're having plus k over 2 all square. That's k square over 4 plus k square over 4. That's what you'll be having here. Now, notwithstanding this, let's look at this critically. The next thing we'll do is to get x minus k over 2 all square. That's what we're gonna do. X minus k over 2 all square. X minus k over 2 all square is equal to 20 plus k square over 4. Now if you look at this, you see x minus k over 2. This is x minus k over 2 up here, and it's equal to 6. So we're just going to replace that inside here. X minus k over 2 all square is equal to 6. So let's do that real quick. So we have 6 square is equal to 20 plus k square over 4. Now this is 36 here. Move 20 to the other side. You have 36 minus 20. 36 minus 20 will give you 16. 16 is equal to k square over 4. I know you already seen the answer. 4 times 16 is 64. 64 is equal to k square. So that means k is equal to 8. So let's move forward to question number 3. So here in question number 3, which of the following is an equivalent form of the equation shown above, from which the equation could be solved by completing the square. So you have this x squared minus k over 3x equal to 5, and let's solve this using completing the square method. When you want to solve it by completing the square method, you're going to get half the coefficient of this. This is k over 3 minus k over 3 all square. K over 3 divided by 2. When you divide it by 2, that's multiplying it by 1 over 2. So you'll be having k over 6. Since if you multiplied it by 1 over 2, it's the same as dividing it by 2. So this is k over 6. Your coefficient is k over 6 all square. That's half the coefficient of x, k over 6 all square. So you just have x square minus k over 6 all square equal to 5 plus k square over 36. I said, which of the following is an equivalent form of the equation shown above, from which the equation could be solved by completing the square? So we have already seen this. We have seen this shown here. This will be x. This is 5 plus k square over 36. So I'm seeing something here. if you're adding this thing to both sides, when you're adding it to both sides, you're having x squared minus k over 3x plus k squared over 36, which is that stuff here. That's k squared over 36 equal to k squared over 36 plus 5. So this is the answer here. This is the answer. You notice that this is going to definitely go out when you are really solving. You can write it like this, but I showed you straight up that you should take it out. They always take it out, you don't keep it. You have plus k squared over 36 and you simply solve for your answer. Alright, so let's clean this up and let's move on. So this question here, x squared minus arrow x equal to k squared over 4. So if you want to solve this by completing the square method, which is quite a simple way of solving this, we'll be having, because half of the coefficient of x squared is arrow over 2. So we have arrow over 2 or minus arrow over 2. Then we square minus arrow over 2. Let's square that. If you square minus arrow over 2, you'll be having arrow over 4. You're having plus now. Arrow over 4. Okay, arrow square over 4 rather. Arrow square over 4. So we're going to add that to both sides. We're having x squared plus arrow square over 4 equal to k square over 4 plus arrow square over 4. That's what you get. So we're having x minus x plus arrow over 4 all square over 4 all square. Now look at this, k squared plus r square 4 is the LCM, so we can join them together. So you'll be having at the other side, you'll be having the square root. We are already square rooting it. We want to clean up this square root so that we'll just square it immediately, because normally we're supposed to just arrange the 24 with square root it. Let's just square it at once. So we have a square root of k squared plus r square all over 4. So since we're having that, let's this is kx plus r over 4. So let's move the arrow over 4 to this side. You'll be having oh sorry, this place there was a minus here. Right, there was a minus here. Sorry, there was a minus here, so it's minus here. Minus at this point, sorry. Minus, there was a minus here. Sorry. Now please, whatever comes out here minus r square over 4. This becomes r square over 4, because minus r times square is r square over 4. But that doesn't have anything to do with this the symbol here. This symbol is always standing. This symbol stands, always stands. You're only handling this one and then squaring it, and you get a positive number, of course. But this stands, the negative here stands. That's because the negative is coming from a different place entirely. It's coming from when you factorize. Okay, it's coming from the factorization. But just know that this negative symbol stands, so it's very easy for you to do. So when you move that, here it's negative 2. So when you move it arrow over 4, so when you move it to the other side, you'll be having positive arrow over 4 plus minus k squared plus r squared over 4. Where is that? Arrow over 4 plus minus k squared. Let's look for it. Arrow over 4 plus minus k squared plus this is not correct. that? Okay, here we see everything here is square root, so square root of 4 is 2. So I think we have found it. This is the one. R over 4 plus minus. You see they separated the square root. These people are crazy. They separated the square root. Okay, they separated the square root. They brought it up a little because everything here is square root. So when you square root 4, you get 2. So this is the answer. See here. You have to be very careful and watchful of the answer, so you not pick a wrong thing or say, there's no answer. Yeah, it's just to check it very well. This one, the square root of everything here. So this one, the square root of this 4 will give it 2. So, and they just lifted the other part of the square root up. Okay, so let's go. So on this question number 5, if x minus 7 into x minus s, x squared minus rx plus 14 for all values of x, what is the value of r plus s? From x equal to 7, x equal to s, that will now give you x squared minus rx plus 14. I think what we can do here, yes, we can do difference of two squares for one of them, and if this is equal to this, okay, and let's just solve one of this, and then let's see what we get. If you're having x squared minus rx plus 14, it's impossible to get to factorize this so that you now check. No, it's impossible, almost impossible to factorize that. So what you can do is to do difference of two squares in this place. You can do the difference of two squares to get the two factors of this place. You can do the difference of two squares to get two factors, or hypothetical two factors. And once you get the two factors, we can proceed. Alright, let's see how we can go about that. Let's see. So another way of doing this is to expand this. Let's expand this first one. Let's see what we can do. So we have x squared minus sx minus 7x plus 7s. Wow, we have already got the answer is equal to x squared minus rx plus 14. Now, how do I know that we have got the answer already? Look at this. The constant term 7s must be equal to the constant term 14. No, constants must be equal because even the coefficients of x must be equal to this, and then because x squared is x squared here. Now, if both of them were not x squared, let's say like something like 2x squared, then we would have divided everything first by that coefficient of x squared, so that x squared will look like this other one's x squared. We call it relational math. Okay, so we have 7s equal to 14. If 7s is equal to 14, that means s is equal to 2. So we have gotten s is equal to 2. Now let's look at another one. X squared minus sx minus 7x. Now let's factorize it. Let's factorize that. We've gotten s equal to 2. We're coming to that. See. So let's look at that s equal to 2. From here, minus s minus s. Let's make x. Let's make x. Let's keep x outside. So we have minus x into s plus 7. You see that? Minus s equal to x plus 7. That's the reason why I'm keeping it as minus x outside, because you see this one is minus x times r. So from what you're seeing, r is equal to s plus 7. You see that? r is equal to s plus 7. This r here is equal to s plus 7 because minus x is minus x here. So we have r equal to s plus 7, and we know that s is 2, so r is equal to 9. So we now have r equal to 9. Now from here, r plus s, which is 9 plus 2. 9 plus 2 is 11. That's our answer. 9 plus 2 is 11 from here. Alright, that's it for this. See, you expand it, and then we look for how it relates, the constant terms, and then the coefficient of x, and whatever the coefficient of x arrow is following, matching with the other coefficient of x at the other side, since they are equal. Alright, let's move on to question number 6. If x squared minus 3 over 2x plus c is equal to x minus k all square, what is the value of c? Alright, so we're gonna try this one. Okay, so if you're having x squared minus 3 over 2x plus c and it's equal to x minus k all square, if you expand this, you'll be having x minus k, x minus k, x minus k, x minus k. So it is x squared minus kx minus kx minus kx plus kx minus kx minus k square plus k square plus k square. That's it. And if you're doing this, if you're solving this, you'll be having x square minus k minus k is minus 2k. This is still a way of relational math. Okay, why is it relational? Because I know that whatever I get here, it will symbolize whatever is here also. Okay, because when I expand this, I'll be having that. Alright, let's go. So after getting this, I've gotten the expansion of that x minus k square. You can use your expansion, your fast expansion method to do that. So if I have x squared minus 2k, I want to write it up here, 2k plus k square, and it's exactly equal to this one, x squared minus 3 over 2x plus 2 over 2x plus c. Okay, so they're equal. If they're equal, you see x squared, the coefficient of x squared and x squared are equal. This c is equal to k squared. Remember that c is equal to k squared. But let's look at this one. Minus 2 is minus 2kx. Sorry, minus 2kx. This is minus 2kx. Yes, minus 2kx. That's from x squared minus 2kx plus k squared. Okay, minus 2kx plus k squared. So this minus 2k is equal to 3 over 2. But look at it, this is minus x and this is minus x. So 2k is equal to 3 over 2. 2k is equal to 3 over 2. Related, relational math. This is minus x, this is minus x here. So 2k is equal to 3 over 2. While c is equal to k squared. We wrote that out down up here. So if 2k equal to 3 over 2, carry 2 to the other side, you have k is equal to 3 over 2 times 2. That will give you 3. And you multiply by 2, cut, and then you have k equal to 3. Now, since k is equal to 3, you can drop it here. C equal to k squared, which is 9 squared, which is 9. That's 3 squared, which is 9. So I've gotten c as 9. Now let's clear this up and let's proceed to the next one. So from what we did yesterday, these questions are quite easy to solve. You already know how to solve them. So you are using formula method, and that's what we talked about here. And all these ones, we talked about using formula method to solve each of them. And look at question number 2. Sum of all values of x that satisfy there's 3x squared minus 12x minus 29 is equal to 0. So all we needed to do is solve it by a quadratic method, and then whatever values of x you have, the two values of x that will come up, those two values of x that come up, add them together. That's what your answer is. Then so in this question here, we're saying that the quadratic equation over there has just one solution. We're looking for the value of k. Now if it has just one solution, then we could use our formula method to get it. We could also use completing the square method in order to get this. But so let's pick any of the methods to solve this. Using the quadratic formula, we could get this. But when they tell you that it has exactly one solution, that means whatever you get inside your quadratic your square roots, in your quadratic equation, you have minus b plus minus b squared minus 4ac. Now what we're saying is that if it has just one solution, exactly one solution, whatever is inside this b squared minus 4ac, this is what usually make your equation to change. This is what usually make it. It's saying that whatever is inside there, b squared minus 4ac, whatever is inside is equivalent to 0, because everything in there will cancel out, and become 0. So that only one solution will be there, because minus b plus minus 0 should give you just minus b. Okay, minus b over 2a. Okay, because everything here over 2a. So b squared minus 4ac is over 2a should be giving you this b squared minus 4ac here should give you 0. That's just it. Okay, so let's go play with that. So if b squared minus 4ac should give you 0, b squared minus 4ac in there should give you 0. And yeah, let's try that. So let's go with that. B squared minus 4ac equal to 0. What is b squared? That's 36 minus 4 times, what's a? A is k, 4k. What is c there? C is 4. So we have 4 times 4, that's 16. We have 16k equal to 0. So let's move this to the other side. We have minus 16k equal to minus 36, and k there, k is equal to minus 36 over 16, minus 36 over minus 16. Okay, minus 36 over minus 16. Now minus 36 over 16, if you reduce that, you have 4 going to 36 will give you 9, 4 going to 16 will give you 4. So you are writing the answer 9 over 4. That's the answer to this, because if it has just one solution, remember what I'm saying, if it has just one solution, whatever will be in here should be equal to 0. Now we have said that because if there was any other thing in here, if there was any other thing, even though it's negative, if it's negative, you'll be having a complex root. I told you about that yesterday. If it's negative, what b squared minus 4ac gives you something negative, it will be a complex root, because square root of a negative number is not allowed. So you're using I to now remove that negative square root. So it will be I anything you get. So your answer will be minus b over 2a I over this anything, because it's negative here. But what we're saying is that if this is negative, it's complex, the answer will be complex. But if it is positive, then the answer is real. Remember, real root. is a real root if it is b squared minus 4ac is greater than 0, it's positive, then your answer is real. Or b squared minus 4ac is less than 0, then it's complex. But if b squared minus 4ac is equal to 0, then there is just one solution. Why is there just one solution? Because if here is 0, then your only answer is minus b over 2a. Finish. So that's just what we are using to solve this. B squared minus 4ac equal to 0, you replace and you get k equal to minus 36 over 16. Alright, so you have your answer 9 over 4 there. That's the explanation I told you I will try to explain to you after we learned difference of two squares. Okay, let's move to the next one. So here we have question number 4. Y equal to bx minus 3, y equal to ax squared minus 7x. In the system of equation above, a and b are constants. For which of the following values of a and b does the system of equations have exactly two real solutions? If you have exactly two real solutions, then b squared minus 4ac should give you a positive number. Okay, b squared minus 4ac should give you a positive number, and that's what we're gonna do. We're just gonna substitute bx minus 3. So before we start solving this, let us go into the preliminary page and try to understand all the concepts and really quick, and return back here to solve it. I just want you to get all the idea. Now you know your quadratic formula, and your quadratic formula usually give you two roots. Now sometimes it will give you one root if we have talked about, if you have 0 as it. So we call that b squared minus 4ac, we call it the discriminant. Now we say that if the discriminant b squared minus 4ac is positive, then you have two real solutions. Okay, for example, if 49 you have 7 and minus 7, so you'll be having two real roots of the equation. That's two answers to the equation. But if you're having 0, that means you just have one solution to that equation. The solution to that equation is that minus b all over 2a. Then if you're having a negative, like I mentioned, you'll be having complex numbers. If you're having no real roots, and those no real roots, they're not real numbers, they are complex numbers. That's what I mean by no real roots. So like this square root of minus 7, it will give you I, then whatever root 7 is, I root whatever root 7 is. That's I is there is to cover your negative square roots there, which actually doesn't exist. So you just tell you that it's in a complex plane. Whatever number comes out from there is in a complex plane. Then you see when you have your graph here, you see the graph crosses the x-axis twice. So you have your answer negative and your plan being positive, and you see your point, your vertex, and stuff like that. Now graph touches the x-axis once, you see it. Now you see when this one is negative, you see the dome this way. When this one is positive, you see the dome this way. Then the graph does not cross the x-axis. You see, for the ones that have two real roots, you see it has both across. It has it on both sides. The graph has it on both sides. Then for the one that has just one solution, the solution it was going to cut the y-axis, but it will never touch the x-axis. It will just touch the x-axis one point, and which is usually the vertex. Then it will cut the y-axis at another point, which is the intercept. There we have this is 4. To cut the y-axis at 4, but touch the x-axis at only one point. That means it has just one solution, x solution. That's what it means. You see, because it has one x answer, so it touch it only once. That means it's only once then. But this one, you see, it touched the x-axis twice, meaning that it has two solutions, whether it is or curved like this or it is upside down like this. As long as it touched the x-axis twice, so there will be two real solutions. But this one that there's no real root, if there is no real root and it's in the complex plane, that's what it will not touch. It will not touch the x-axis at all, because it does not have real solutions. It's not a real number, it's actually a complex number, and the complex number exists within the plane itself. And you see, it doesn't even cut the y-axis at any point. That's because x is not even 0. If it cuts the y-axis, then x will be 0 at one point in time. So if it even had a solution like x equal to 0, at least it would have cut the y-axis, but it doesn't cut the y-axis. That tells you that it is has no real solutions because it doesn't cut the x-axis. So in case you come across a question where they give you different graphs and they tell you which of them has no real root, just know that the one that doesn't cut the that doesn't cut the y-axis to make x equal to 0, it does not have a real root, and it doesn't touch x-axis at all. It has no real root. While the one that cuts that touches x just once have just one solution of x if it touches the x-axis once. While the one that touches the x-axis twice have two real roots, two answers to the equation. Alright, and even then it still has almost like a third answer in a way, because x could be 0 here. So that's it. Let's proceed. So now let's return back to the question. Saying the system of equations above, a and b are constants. For which of the following values of a and b does the system of equations have exactly two real solutions? I said what you need to do is replace this y bx minus the following values of a and b. The system of equations have exactly two real solutions. So what we are going to do here, for it to have two real solutions, that means the discriminant must be equal to must be greater than 0. That is, must be positive. The discriminant, remember what we said about discriminant. The discriminant is b squared minus 4ac. So b squared minus 4ac should be able to give you something that is greater than 0. So we're just going to test each of them. Here we're having a as let's try 3 as a. This is 4 times 3. 4 times 3. You know c is minus this 3 there. C is 3. Okay, let's just arrange it very well so that you understand it. The first thing we do is to arrange our equation. We have ax squared minus 7x minus bx plus 3 So when you arrange this, you know what b is. B here becomes minus 7 minus b. That's what b is. Minus 7 minus b. That's what b is. So we're going to square it. That's b squared minus whatever 4ac. So this is what we're using as b squared, and then we're using 4ac. That's the discriminant. Whatever we get here must be greater than 0. So we're going to test all these options here: 3, minus 2, 5, 0, 7, 2, and 9 and 4. We're going to test them. It must whatever we get must be greater than 0. So let's punch it in. The first one we have b as minus 2. Minus 7 minus 2 is minus 7 minus minus 2. That's minus 7 plus 2. That is minus 5. Minus 5 squared is 25. Now what concerns us most, we have gotten 25 here. Let's check this other one. 4 times a, 4 times 3 is 12 times c. C is 3. You see c is 3 here. So 12 times 3 is already more than 25, so that's not the answer. Let's check this other one. 5 we have 5 here as a, and then we have b as 0. So if b is 0, minus 7 minus 0 is gone, so it's minus 7 squared. That's 49. We have 49 for the second one. 49 minus, let's say 4ac. 4ac is a is 5 there. 4 times 5 is 40. 40 times 3 is already more than 49. So this is not the answer either. Let's try the next one. 7 minus 7 minus 2. Minus 7 minus 2 is minus 9. Minus 9 squared is 81. So let's punch 7 in. 4 times 7 is 28. 28 times 3. 28 times 3. This looks like it's the answer. Let's see. 28 times 3. 3 times 8 is 24. 3 times 8 is 24. 3 times 2 is 6 plus 2, 84. Oh, this was close. 84. but 81 is great. 84 is greater than 84, so it is to be negative. Let's try the last one. 9 and b equal to 4. So minus 7 minus 4. Minus 7 minus 4 is minus 11, and square minus 11 square is 121. So let's try that one. 9 times 4 is 36. 36 times 3. Let's see 36 times 3. 36 times 3. Let's try that. 3 times 6 is 18. 3 times 3, 9 plus 1, 10. 108. We have gotten the answer. 108. 121 minus 108 is positive. So this is the answer here. Quite an annoying question. Let's go to the next one. So we have this one. What are the solutions to x squared minus 4 plus 4 equal to minus 6x? Let's just arrange this well. X squared minus plus 6x rather. X squared plus 6x equal to carry minus the answer. I have minus 4. So let's see. So have the coefficient of x is 6 here. Let's use difference of two squares. So we have 3. If 6, so we are adding 3 squared to both sides. That's minus 4 plus 9. See that? Difference of two squares is very interesting because you just do half of 6. Completing the square method rather, not different. This completing the square method is quite easy because you just divide this by 2, especially when it's an even number. You can easily do it when it's an even number. So you just divide it by 2, you have 3. Square it and add it to this other side, you have minus 4 plus 9. Then just write x, whatever symbol you see here, plus, you put it there, plus 3 all square. And that's it. So you have minus 4 plus 9, which is 5. Because of this square, you square root it, and then your x equal to, carry this your plus 3 to the other side, you have minus 3. So your answer is minus 3 plus minus 5. And you see, you have gotten your answer so fast without much ado. Remember the steps. The first step, you just simply divide your coefficient of x by 2, square it, add it to that side, then write that number, that your coefficient of x, write it, and then square it with x plus 3. Whatever symbol is here, put it here. Okay, then you now simply square root the other side, whatever you get on the other side. When you square root it, carry this one to the other side and just minus. That's it. Very simple. Okay, let's go to number 6. Number 6, which of the following equation has no real solution? Which equation has no real solution? I have 5x squared minus 10x equals 6. If it has no real solution, then the discriminant should be negative. The discriminant should be negative. The discriminant should be negative. So we could use b squared minus 4ac. We could use b squared minus 4ac to get that, but that may take longer. It may or may not take longer. We don't know. But in order to do that real quick, we just whatever is here, square it. Whatever is here, square it. Square whatever, half of it. You can either get half of it, square it, and then add it to that side, or you just simply say let's just use b squared minus 4ac. B squared minus 4ac. So this is b squared minus 10 squared. Minus 10 squared is 100. 100 minus 4ac. 4, that is for this. Please bring this 6 in, so you have minus 6. Don't forget, if you keep this 6 separately, you may have a negative. You may use a wrong answer. So you have minus 6 times 5. Minus 6 times 5 times 4. Minus 6 times 5 will give you minus 30. Okay, minus 30 times 4 will give you 120. So, but it's minus 120. So we're having 100 plus 120 in here. So it will be a real solution. So let's try this other one. So you have 4ac. This is b squared, 64. Yeah, 64. Minus 4ac. 4 times 4, 16 times the 4 there. That's 64. So we have 4 square, which is 64 minus 64. So you see, to have just from this one, you have 64 minus 64. This one will only have one solution to this equation. To have one solution, because 64 minus 64 is 0. You see, so because 8 square is 64. 4 times a, which is this, 4 times 4 is 16, times 4 is 64. So this one has just one solution, but that solution is a real number. It's a real number because square root of 0 is 0, but that solution is a real number. Very important. The solution is a real number. The solution there is just minus b over 2a. Okay, so but the solution has an answer. Okay, now let's try the next one. We have c 3x squared minus 5x minus 3. So we move this minus 3 to the other side. Okay, so you have plus 3. You have plus 3 as your c. So now let's do minus 5 squared is 25. That's b squared. 25 minus 4 times 3. 4 times 3 is 12. 12 times 3 is 36. Oh, we have seen the answer. 12 times 3 is 36. So this will give a negative answer. If this gives you a negative answer, that means it has no real solution. Let's try this last one. Let's see if there may be 2 answers possible. We have minus 1 over 3 times 2 here, 2 square, which is 4. Then we have minus 2 times minus 1 over 3 times 4. Minus 2 times 4 is minus 8. Minus 8 times minus 1 over 3, that's minus 8 times 1 over 3. So that's minus 8 over 3. Minus 8 over 3 times this is minus times minus. Okay, this is plus. So we have minus 8 over 3. 8 over 3 is definitely less than 4. So whatever this will give you a positive answer. This will give you a positive answer. So this is not the answer. It has a real solution. So because it's a positive answer. Alright, so that is your answer. Your answer is C. Form the equation of the line. So we have y equal to a into x plus 4 and x minus 2. Why do you think we're putting the a? We're putting the a because this is a curve, upside down curve. This is a upside down curve, and the upside down curve, must be a negative. So that a stands for the negative that makes this a curve upside down. If the curve is this way, then it is positive. You don't need to put the a. You just add this plus this. But this a here represents whatever negative that's making it curve upside down. So that's why we have a here. So we have a into this when you solve. Now let's look at putting x as 0 and 16 over 3, like y as 16 over 3 and x as 0. You can get what y is. So you put 16 over, you can get what a is rather. 16 over 3 equal to a into, let's put the x as 0. 4 times, you put 0 minus 2, 4 times minus 2, that will give you minus 8. So if you carry minus 8 to the other side, you're doing 8. This 8 times minus 8, carry minus 8 to the other side, you're having 16 over 3. I think we should crop this into our main board. Let's just crop this into our main board, and so we can solve. So scrub this into our main board so we can solve. Let's go. So having this in mind, we're gonna solve. This is 16. This is 16 over 3 times minus a divided by minus 8. Well, that's like times. Sorry, this is x plus 4, which is 0 plus 4, 8, and this is, yeah, that's it. So you have times here. You move it to the other side. You now divide it. 16 over 3 divided by 8. Yes, 16 over 3 divided by 8. You have 16 divided by 8. That will give you 2 over 3. So, and not just 3 over 8, because this is minus. So This is minus 2 over 3. You see that minus 2 over 3 is what makes this curve upside down. I told you that's what makes the curve upside down. So after doing that, the next thing we're going to check, since we have gotten a as minus 2 over 3, we now know our equation x a minus 2 over 3 into x plus 4x minus 2. Now from this line, we can get the vertex. We can get this vertex, so and then use that vertex and get whatever y value we have for the vertex. Once we get that equation, we get the vertex, we can now decipher what that point is, which is this line. We can now get the line, that point of the line. We can know what that point is, so that we can get the slope of the line. Once we get the slope of the line, from the slope of the line we're going to get the equation of the line, and then we'll now get whatever intercept this is, because this is what they're asking for. They said through the point V and the y-intercept and the intercept of the line. So that's what we're going to do when y is 0 for this intercept here. That's what we're looking for. So we have minus 2 over 3. Okay, we have minus 2 over 3 there, and that's it to x plus 4 x minus 2. We don't have too much time to start expanding that, but coming to this, so that's y equal to this. That's the equation of the line, y of the curve, y equal to this. So we're looking for this point. So if we're looking for this midpoint, in order to get the midpoint, from minus 4 to 2 is about is 6. So if you count 3 from both sides, you can easily do that by doing minus 4 plus 2, and then you divide it by 2, you will get minus 1. This is minus 1. So this is the middle point for my x. X is minus 1 at the vertex. So drop minus 1 into this equation, you're going to get what y is. So y is equal to minus 2 over 3 into minus 1. Minus 1 plus 4 is minus is it minus 1 plus 4 is 3, and then minus 1 minus 2 is minus 3. So we have 3, 3 and minus 3 here. Okay, so we can cancel this 3 and this 3 here. So we have minus 2 times minus 3, which is minus 6. So y is equal to minus 2 times minus 3 is 6 rather. So y is equal to 6. So that point there is 6. So we now know that for your slope, you have, from y equal to mx plus c, we're talking about the line, equation of the line now. From y equal to mx plus c, from the slope here, this is 2 comma minus 6 there. So we have the slope m is what we're trying to get. The point, this point here is 6. So we have 6. Sorry, let me clean this. We have 6. We have 6 minus, we have 2 there, 6 minus 2, which is 4 over we have minus 1 and 0. So we have 6 over 2 minus 1. So that will give you 4 minus 1 minus 0. So that's minus 1 minus 0. No. The y is 6. This y is 0 here. So it's 6 minus 0. 6 minus 0, and here is minus 1 and 2. So it's minus 1 minus 2. Yeah, minus 1 minus 2. So that's it. 6 minus 0 is 6, and minus 1 minus 2 is minus 3. So your slope there is actually minus 2. Okay, so that's your slope. 6 here minus 0, and then x here, which is minus 1 and 2. So we have gotten that minus 1 and minus 2. So we have gotten the slope as minus 2. Now since we have gotten the slope, let us write the equation. Let's write the equation out well. Now we're going to have y equal to minus 2x plus c. Okay, what's crazy is that we know that this place was 6 at minus 1, so we can decide to insert that into the equation. We can insert it into the equation. This was 6 equal to minus 2. That's minus 2 minus 1. So what's that? Minus 2 minus 1. Minus 2 times minus 1 is plus 3. So plus 3 plus c. Okay, so 6 equals to plus 3 plus, so what's c? C is 3. We've seen that c equals to 3. So what is it at 0? What is it at 0? So when y is 0, we know that x is when y is equal to 0, we know that the intercept c is 3. So I've gotten an answer there. Let's go check. It's 3. Let's go check. Is that true? Let's confirm very well. Let's confirm, because it's 0 equal to minus 2 plus c, and x equal to also 0. That's y equal to when y is equal to a certain number, y equal to when x is 0. So y equal to minus y equal to c, and put 6 in here. 6 equal to minus 1. So 6 equal to minus 2 times minus 1. Minus 2 times minus 1 is minus 2. Sorry, minus 2 times minus 1 is plus 2. Plus 2. Sorry. So 6 equal to plus 2 plus c. So c is definitely 4, not nothing. I was just trying to check and I found my mistake. So 2x, since x is minus 1, minus 2 times minus 1 is plus 2, and then plus c equals, so x equals 4. So let's go check our answer if we have this. Oh, sorry. Alright, so we see our answer there as 4, c equal to 4. So that's it, we are correct. Alright, so let's move to the next one. So in the system of equations above, a is greater than 0. If the system of equations has exactly one real solution, what is the value of a? We have talked about this one real solution, just one solution. That means your whatever you have as your value of b squared minus 4ac. b squared minus 4ac, if it has just one real solution, should be equal to 0. b squared minus 4ac should be equal to 0. That's what we said. b squared minus 4ac should be equal to 0 for it to have just one solution. That's because the square root of that c should be equal to 0. So let's arrange this. If y equal to this, we have x squared plus x plus ax, I think x plus ax, so we have ax plus x. Is it plus x? If you arrange this, carry this to the other side. If you carry this to the other side, you're having ax we'll be having minus ax, so minus ax, so we're having x minus ax, so it's plus x minus ax, then we're having plus 1 at the other side, because we equated them first and then we rearrange it. So x squared plus x minus ax plus 1 is equal to 0. So arrange this very well. You'll be having x squared, we'll be having x squared plus x into, let's make x solve it, let's make it in factoring it. X equal to 1 minus a plus 1. So our b is 1 minus a, so we're having 1 minus a all square, 1 minus a all square minus 4ac. What is a itself? A is 1. So if a is 1, and what is c? C is 1, so it's just minus 4. So whatever you do here, 1 minus a squared minus 4 should give you something that must be equal to 0. It must be equal to 0. So let's test what we can test. So if you have a as 5/2, 1 minus 5/2 all square, 1 minus 5/2 will give you, this 5/2 is 2.5. 1 minus 2.5, it won't give you something that will minus 4 equal to 0. It will not equate to 0. Let's try 3. 1 minus 3. 1 minus 3 is minus 2. Minus 2 square is equal to 4. and 4 minus 4 equal to 0. We have seen our answer 3. And they said a must be greater than 0, and that's the only thing. 3 is greater than 0. Alright, let's proceed. Let's clear this up. And let's move to number 3. So here in question number 3, say the function f and g defined by f of x equal to 2x plus 2 and g of x minus 2x squared plus 18 are graphed in the xy plane above. The two graphs intersect at the point AB and minus AB. What is the value of b? Very good question. Okay, so we have 2x squared plus 2 there, minus 2x squared plus 18. For them to be graphed into the equation, and for them to even have points that are close to each other, you'll be having you'll be understanding that for their solutions, for their graphs to be for those points where they meet, that means the solutions of their equations are the same. That means in fact the equations are the same at that point, at those points A and B. So let's equate those equations. So you have 2x squared plus 2. 2x squared plus 2 is equal to minus 2x squared plus 8. So we just add them together. Add them to 2x squared. This plus 18. When it comes to this other side, it will become minus 18. So we have this. Okay, 2x squared plus 2x squared will give you 4x squared. Okay, 2x squared. Move this to the other side. You have 4x squared. And 4x squared, you now have 2 minus 18. 2 minus 18 is minus 16. So you have 4x squared minus 16. Now, if you look at this equation, 4x squared minus 16, and they are at 4x squared minus 16. See the 2 points. Let's find solutions to 4x squared minus 16. 4x squared minus 16. The solutions to this quadratic equation now have 2 points. You see, 4x squared minus 16, if you say that equal to 0, but although in this point they're not actually equal to 0, they're just 2 points. Okay, so let's just factorize this. You have 4. See, this is 2 square x square minus 4 square. Now you see all of them having square, so you can handle them specially. You can just say 2x minus 4 all square, since all of them is all square. Yeah, you can put it all square. So if you put it all square, your answers to this will be 2x minus 4, 2x minus 4, 2x. You know, in fact this is difference of 2 squares, so 2x minus 4, 2x plus 4, 2x minus 4, 2x plus 4, because this is difference of 2 squares, 4x squared and 16. So we have 2 square x squared minus 4 squared, so it's 2x minus 4, 2x plus 4. Okay, clean this off. We're just trying to explain. So it's 2 square x squared minus 4 squared is this. We'll give you 2x minus 4, 2x plus 4. And when you do that, 2x minus 4, 2x plus 4, you're going to be having, if you're having let's look at AB and minus AB, AB and minus AB. So those are the two answers, and let's see that. So the B there are the y, and y the a's are the x. So let's see what we get here. So 2x minus 4, if both of them are equal to 0, or if both of them are equal to a certain y value, okay, because you see these points that are at a certain y value, both of them will give you certain y value equal to 2x minus 4, 2x plus 4. Okay, so at that point, at those points where they will give you 2x minus 4, 2x plus 4, let's clear this. I think we should, let's pick this into our, let's just pick this into our, let's pick it into our to position. So so at the point where they'll give you 2x, because we're having 2x minus 4 and 2x plus 4, two different equations, two different ones, and they're equal to a certain y value, which is at this point here. It's at this point. This is the y value here, the y value. So so you can say your y is equal to, because we have you have a certain x value here, certain x value here. So let's just make it 0. Like, let's just make it 0. So 2x is equal to 4, while the other one is 2x is equal to minus 4. So what's x? X equal to minus 4 over 2, which is minus 2, while this one x equal to just 2. So you have your two values, 2 and minus 2. So now if you want to know your a values, your a values here is 2 and minus 2. You see, 2 and minus 2 are your a values. And then b, want to know what b is. You see, b are the same in both. So put your 2 into the minus 2 into this. You have 2 times minus 2, 2 into minus 2 to give you, of course, to try to give you 0. So just put, since we have gotten x as 2, drop it into any of them. Into any of the equations. Let's go. 2 into minus 2 there. Minus 2 square will give you 4. 2 into 4 as 3 times 4 plus 2. 2 times 4 plus 2 will give you 8. 8 plus 2, that's the 10. Then put it in here. Minus 2 or x squared, so minus 2. Okay, minus 2 times 2, minus 2 times, this is 4, minus 2 times 2 square. Even though you put minus 2 square, you still have 4. So minus 2 times 4 plus 18. Minus 2 times 4 is minus 8. Minus 8 plus 18. Minus 8 plus 18 is 10. So your answer is 10. Either way, you still get 10 for your value of b. So let's clear this up and go back to answer. Let's go back to our book desktop and then let's see our options. Yeah, 10 is here. So that's our answer here. Alright, let's look at question number 4. This is question number 4. I think this is the last question you can take before you go into your test questions. Okay, question number 4 says x squared plus y squared equal to 14. X squared minus y equal to 2. If x or y is a solution to a system equation above, what's the value of x squared? This question is not too far-fetched. It's not too hard to decipher. All you need to do is what is y here? So move y. You have x squared minus 2. X squared minus 2 is y. X squared minus 2 is equal to y, and then you have y squared is equal to 14. We can also, another thing we can also do is by equating this the other way. Let's do this in a nicer fashion. You can do it anyhow. We could do it the other way. You can still do it this way. So let's try it. So this is x squared is equal to 2 plus y. 2 plus y. Now carry that into this place. You have 2 plus y square equal to 14. This is a quadratic equation. Okay, 2 plus y square equal to 14. So y square plus y plus 2 equal to 14. So rearrange this. We're having y square y square plus y. Addition is commutative. 14 minus 2. 2 minus 14 rather is minus 12, so equal to 0. So you know your two options will be 4 and 3. 4 and 3 here. If you want to use this thing, if you want to use a quadratic factorization method, where you have y squared into 4y minus 3y minus 12 equal to 0. And so your two options would be y plus y plus 4 sorry, yeah, y plus 4 where you're having y and minus 3, so my minus 3y minus 14, so we have y minus 3, and that's y equal to 3, and y equal to minus 4, so if you have these two values of y equal to 3 and y equal to 4, let's put it inside here as this. So x squared minus y, so carry this into the side, carry, let's say 3, so you have 2 minus 3, so x can be 1, so that's 2 minus 3. X could be 1, but on the other hand x could also be 4 minus 4, so let's put y could also be minus 4, so let's put y minus 4 here. So that's y minus 4, carrying to the other side, you'll be having minus y there, that's plus y, that's minus 4. So we have x squared equal to 2 minus 4. That's it. 2 minus 4. That's minus 4 here, so 2 plus 4 y, 2 minus 4. So x squared equal to 2 minus 4. If x squared equal to 2 minus 4, so that's x squared could be just 2 minus 4 is minus 2. If you put 3 here, 2 minus 3. Okay, let's try this other one. X squared plus y squared. What's y squared? Y squared is minus 4 square. So x squared is equal to 14 minus 14 minus, this is 3 square 9. 14 minus 9. 14 minus 9 is 5, because you put minus 4 there. That's 14 minus 16. Yeah, think square, that's minus 4 square is 16, so we have 14 minus 16. 14 minus 16 is still minus 2, so x squared equals to minus 2. Okay, so if x squared is equal to minus 2, you know that if x squared equals to minus 2, if it's minus 2, I think the problem came from this factorization. Let's try it one more time. I think the problem came from here. Let's try it again. Let's see what we get. Let's try one more time. So no, this time let's make x squared subject with formula so that we'll get this. So you have let's make y subject to formula rather. So you have x squared minus 2 is equal to y. X squared minus 2 is equal to y. So let's drop it as that over here. So we have x squared plus x squared minus 2 all square equal to 14. Now if you have x squared raised to the power 2, this is x squared minus 2, x squared minus 2, x squared minus 2, x squared minus 2. This will be way longer. I think we stick to the former one. But I think there was a problem while we were solving that. So let's see. X squared y, this is 2 minus x squared, or we say minus y to the other side is y equal to x squared minus 2. Yep, x squared minus 2. So we could also use this one too. Y squared is equal to 14 minus x squared. 14 minus x squared. And better yet, we do this x squared is equal to 2 minus y. So put that 2 minus y here. Yeah, I think that's it. Y squared equal to y squared plus x squared, which is 2 plus y. That's 2 plus y. So x plus 2 plus y equal to 14. So you have y squared plus y. Still the same thing that we did before. Let's just solve it aggressively now. So that answer was staring at us all this while. X is equal to, since we have gotten y is equal to 3. Since we have gotten y is equal to 3 here. Since we have gotten y equal to 3, and we have gotten x equal to y equal to minus 4. We're just simply gonna put this. So drop this in, x squared minus y. This is x squared equal to 2 plus y. So putting y as 3 here, we have x squared equal to 2 plus 3. That's 5. So x squared is equal to 5. That's the answer. Let's go forward. So the next thing we are gonna do is your test. In chapter 11. So I'm going to screenshot that and send to you right away.